Today we're going to talk about the structure and properties of liquids, and then we'll talk, we'll talk about the different types of solids. Yep, there they are. Okay. Surface tension. When we talk about surface tension, you can think of surface tension as the skin on a liquid. And I haven't seen this very much or very often, but the water bugs that actually walk on water, water spiders, some people will call those. Okay. The reason why they can do that is because water has a very strong surface tension. And surface tension is due to the intermolecular forces, or the bonds between the water molecules. If the bonds between the molecules are not strong, then that water bug wouldn't be able to walk on water. All right. Is it possible for us to walk on water? No. Yeah, when it freezes. All right. Cohesion. Cohesion's just dealing with the strength between those bonds. Okay. So the greater the cohesion, the greater the strength in between those bonds. The strength of the surface tension, and I said that already, is due to the intermolecular forces. So the stronger the intermolecular force, the greater the surface tension. And again, I don't know how many times I can repeat it. Adhesion. You guys don't drive yet, do you? Does anybody drive yet? Yeah. Okay. Do you guys wax your car? Keep it clean somewhat and then wax it. Personally, I don't wax my car. I'm too lazy. When you guys are young, you like your car to look nice and everything. It's just a means of transportation for me. However, back when I was younger and I cared about that, I used to wax my car quite a bit. And when it would rain, that was pretty cool because I'd walk out and what would you see if you keep your car clean and waxed? Would the water just make the coat or the car wet? No, actually little beads of water. Why do you think that happens?
Because they're not the same thing, so it's like with the water bottles when you put like oil and water.
Oh, okay. So the water doesn't like the wax, is that what I'm hearing?
Yeah.
Yeah, okay. Well, if you go to my car and it rains, then you've got this wet coat. There's no beading taking place. There's actually a nice adhesion of the water and the dirt and everything that's on the car. All right. So if you keep your car nice and clean and waxed, then there's this opposing force that the water's like beads up, and actually because that's due to the surface tension of the water, it has very strong intermolecular forces, so it beads up. And then when you turn a corner, all that water goes off to the side, and if you have your window open, then it comes inside the window. Okay? That's why I don't wax my car, so that I don't get my inside wet. Okay? Soap. Soap is really cool, and that the reason why we use soap is to make water wetter.
What?
Exactly. Because soap helps to break the bonds between water, and it actually makes it a nice wetting agent. It actually helps reduce the surface tension to make water wetter.
Oh.
Also, it's nice in breaking up grime and dirt and whatnot. Structure and property of solids. Okay. In AP Chemistry, we'll talk a lot about solids. We're not going to do a whole lot with this. I just want you to know the different types of solids, because it'll be on the test. Okay. It'll be a while. It's not next week. Amorphous solids. Amorphous solids mean that they don't have a regular pattern or arrangement. When you get into the science of solids, really exciting. I'm kidding. There's definite arrangements. There's crystalline arrangements, and if you get into it big time, you'll find out all the different shapes that solids actually form to make it strong and solid. So an amorphous solid means that it doesn't have a regular pattern or arrangement. Okay, it's just very, very random. Metallic solids. What do you think make up metallic solids? Metals. Okay. So if you only have one kind of metal or a combination of metals, like some of you may have brass water faucets at home, that's a combination of copper, nickel, some zinc, some other metals that are in there, makes an alloy. That's a metallic solid because there's nothing in there but metals. So on the test, if you see something that says, hey, I've got this type of metal, make sure that if I'm asking what type of solid it is, you know it's a metallic solid. You don't want to miss that. Covalent network. What this is only nonmetals. Okay. So when we talk about a covalent network, we're talking about one kind of nonmetal. So a good example of a covalent solid is diamond. What are diamonds made up of? Carbon, just carbon, okay? After it's undergone a lot of pressure and a lot of energy, all right? But diamond is made up of the same thing as the lead in your pencil. Okay, it's not really lead, but it's graphite. So those are examples of covalent solids. So you have one type of nonmetal, okay? So if you want to write next there, one type of nonmetal. That's probably a good thing to write down for your notes. Where it says covalent network solids, one type of nonmetal. And if you want to write next to metallic solids, only metal or metals. So it's a combination.
One type of what?
Non-metal. I love it how you guys don't pay attention until I say, oh, you might want to write that down because it'll be on the test. It's like everything says wah, 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 wah. Is that how it sounds when I'm talking? Just the wah, wah, wah?
Like the person from Charlie Brown.
Yeah.
Exactly. What did he say? Oh, yeah. All right, molecular solids. Molecular solids are made up of only nonmetals, but at least two different kinds of nonmetals. Like, for example, water is a great molecular solid. It's made up of hydrogen and oxygen. Okay? So when you're categorizing that, and again, sometimes these are larger molecules, but they definitely have higher melting points or boiling points, whatever you want to associate that with. So molecular solids are at least two different types of nonmetals. Ionic solids, take a wild guess of what makes up ionic solids.
I have no idea.
Well, what are ionic compounds made up of?
Ion.
Metals and nonmetals. It's all right. You guys are going to only have this on your final exam in like 2 weeks.
Okay, no big deal then.
No big deal, yeah. Factors that determine the arrangement of molecules. There's a couple factors here. The size of the atoms, okay, determine the arrangement of the unit cell, which, again, we're not going to talk about unit cells, but do know that size does affect the arrangement. That's all you really need to know. The ratio of cations and anions. What's a cation?
Oh, I remember this. We learned it last.
We did. Cations are positively charged ions or metals, okay, metal ions, and the anions are the negatively charged nonmetals. And again, the size does affect the melting point. I need to show you.
Wait, were we supposed to write something next to molecular?
Yeah, two different types of nonmetals.
That's yeah.
And then, for your enjoyment, here's a nice little table summarizing all that. Okay, so when we look at the type of solid, now again, these can exist as liquids and gases as well, but when they are a solid. So the type of intermolecular force that they would have, if you have a metallic substance, it'll have metallic intermolecular forces, which will also be made, it'll be a metallic solid. And we didn't talk about the intermolecular forces for metals, did we? Or did we? I don't think we did.
No.
So here it is. So when you look at the intermolecular forces between metals, they're held together with metallic bonds. What do you think is stronger, the metallic bonds or say like dispersion? Metallic. Why? Because most of the metals at room temperature are a solid. There you go. So again, if you're not 100% sure, look at what it is at room temperature. Its state, whether it's a solid, liquid, or gas. So that, and again, I'll give you test questions like that for you to analyze and think, okay, I've got two different substances. One's a solid at room temperature, and the other one's a gas at room temperature. Which one has stronger intermolecular forces? You should be able to answer that. The covalent network, again, made up of one type of nonmetal, has very weak dispersion forces. Now again, the reason why some of these can be solids at room temperature is because they're heavy. Some of these are very, very massive. So again, the more massive you are, the stronger the intermolecular force, that gravitational attraction. And then molecular solids, again, made up of at least two different types of nonmetals within the molecule. And we have the three different, these are the first type of intermolecular forces that we spoke about at the beginning of the packet. Which of these three is the strongest? Dispersion, dipole-dipole, or hydrogen bonding? Which of those is strongest?
Dipole-dipole.
The hydrogen bonding, very good. You guys got a lot of review to do.
Oh.
And then ionic, again, it's made up of a metal and a non-metal, and it's held together with ionic intermolecular force. This would be a very good thing to study for the test. Again, it's not for a while yet, but definitely make note of that. All right, the 4s are your homework.
Are we done?
We are finished.
Yeah.